Welcome everyone back. We're going to continue on using quads, and this time around we're going to start messing with textures. So the first order of business is you guys need to get a texture. You can either go to Google Image Search and do a search like I did. It was texture test grid image, and you'll find a lot of good textures you can use. Or you can go to GitHub and use a texture I'm using, this 2x2 grid that kind of shows you the UV coordinates. One thing you should know is that any texture you use should be the size of by the power of 2. It's the most optimized way to do textures. WebGL does support textures of different sizes, but if you're done by power of 2, it's just more optimized. It's just quicker mathematically and everything else. So if you want the most performance and least amount of memory used up by the GPU, you should just make sure it's a power of 2. And in case you don't know what a power of 2 is, I gave you an example of sizes. The best sizes for the most part would be anywhere between 256 and 1024, but I usually stick in the middle for 512. So yeah, those last three are probably like the best bet for you, the note of textures. But if you want to have fun by the end of the lesson, maybe you should try to find maybe something 64 or 32, but like of a character, like a Super Mario, pixel texture, or Sonic the Hedgehog. When you reach the end, you'll probably get why I think it might be more fun getting an image texture instead of some kind of test texture. In the previous lesson, we touched upon UVs, and we used them to make square borders and circles. In case you don't fully grasp what a UV is, I'm going to probably explain it a little bit further. Here's an example of our awesome quad, and our quad is made up of 4 vertices, and each vertex we can apply some kind of attribute. Attribute is just another array that has the same corresponding index with just additional values. So we'll have an array of UV values. At some point we'll have normals. I think there's a couple of other things we can have down the line. We can add colors. So those are all kind of just called attributes applied. They're just an extra array of data. So UVs is just an attribute for our vertex, and it applies to a position of a texture. And you can just say it's really just a pixel in the image. What pixel are we trying to reference to? So the way everything works is that each vertex is assigned a UV, and as we interpolate from one vertex to the other, it then picks the pixel in between those 2 spots. So in the bottom, I have UV using the whole texture. So the top left corner is 0, 0, and the bottom corner, the other corner is 1, 1. Those are the 2 main borders, or the 2 regions of our square. But you don't have to use the whole texture for our quad. You can actually use a part of the texture for a quad, like the other example where I start with 0.3 and the other corner is 0.07 or 0.7. In a lot of models, you're actually going to be using parts of the texture. It's never going to be one whole texture applied to a single quad. So in all honesty, the second example is really how it's mostly done, especially when you're dealing with atlases. An atlas is just one large texture that has a bunch of images inside, which then you just use the UV of each section of that image. An atlas would be something like Minecraft. Minecraft has an atlas. If you look up Minecraft atlas on Google Images, and you'll see what I'm talking about. It's just one texture image with every single block face inside that one image. And I think typically each block is 16 or 32 pixels wide inside like a 512 or a 1020 large texture. So that's pretty much the overview of UV. And UV, like I said, is just which pixel are you starting with for each vertex. Now it's time for some code. Let's open up our jl.js file. And the first order of business is to set up an array that will hold all our textures that we have loaded. Again, this is like how we're doing our mesh. So this way down the line, we can unload textures when we need to. Now we scroll down a bit and let's make our load texture function. In this function, we're going to bring in a name of the texture that we want to cache it under, the image tag that's going to be on the page. That's how we're going to actually load the actual images. And we have an option for do Y flip. Do Y flip flips the Y coordinates of the UVs, upside down. So the corner starts at the bottom left instead of the top left. We're making this as an option when you load textures because when I did this for the first time and I was loading up textures, everything was messed up. For some reason, it looked like the textures were like completely mangled. At some point, I managed to find an article that said that Blender actually puts UVs upside down. So even though WebGL does UVs one way, Blender does them in a different way. So what you have to do is that when you load in a texture, you say flip the image upside down. So all it does is that's what it does. It just flips the image upside down. So when you, in an event that uses like a 3D mesh that came from Blender or some other tool that has the UV coordinates upside down, that will fix your problem and not waste hours, if not a day or two, trying to figure out the problem like I did. So this is a nice little warning. If you ever load in a texture from a mesh and it looks mangled for some reason, do the flip or don't do the flip. Just test it either way to see what the problem is. That might be where your problem is. So line 115 does all that flipping stuff for us. The rest of it is pretty explanatory for the most part. Like 117, we bind our texture. Well, let's start with 114. 114, we create our texture, just as like how we create a buffer. It's basically kind of the same thing. And then by line 117, we bind a texture to like a global name that, just like how we did with with buffers and elements. And then line 118 is we're pushing the texture to the GPU. They're using text image 2D. And these are just the basic settings, RGBA and things like that, unsigned byte. It works just fine for PNGs and JPEGs. So this is pretty much a pretty optimal setting for now. And then line 120 and 21 and 22, that sets up how textures will be scaled, as your mesh gets smaller and bigger. So 120 is just upscaling and 121 is just the downscaling. And then 122 is kind of an optional, especially it's kind of tied into 121 because we're saying mip-map nearest. Mip-map, let me try to see if I can explain this correctly because I understand what it is, but I'm still kind of new to it. Mip-maps optimize images or textures for us. Like it creates different versions of it in memory. So you have a high resolution version, a medium resolution version, and kind of like a small resolution version. And as your mesh scales, like from the Z index, it uses that different version. So this way, it makes it less pixelated as you're going from section to section, and it uses up less memory in some essence. Like especially if the image is really far away, so you can use a smaller version of the texture. I think in the long terms, it kind of does use up more memory because it does take your normal texture and then generate a few different versions of it, different qualities of it. So, but it does make the quality better. It makes it less pixelated. And then line 124 is we're just unbinding it and then, saving it to our cache. And then we finish it off by unflipping turning off the flipping setting, because if we turn it on, let's turn it off because maybe the next texture we load in, we don't need to flip the Y. Now that we're done, let's move on to our HTML page. Now, after we're done loading the camera, let's just load our texture. and we're going to give it a name, text001, and we're using JavaScript to grab an image tag that exists on the page that we're going to put on a little later. And then on line 46 and 47, we're going to append another changeable function called setTexture. We're going to fix up our test shader to be able to load in textures. Now we scroll down the page. Now the next thing on the list is unrender. So we're going to fix line 66 and just append another chainable function called pre-render, because now that we're dealing with textures, we need to do a couple of things with our shader before we start actually rendering. Now we're going to scroll down some more, and now we're finally at our test shader. One of the first things we're going to do is add a new property called main texture, and this is going to store our texture ID. Then the next thing up is line 85. We're going to make our set texture. That's all it does is takes the texture ID and save it into our class. And then we override the shader pre-render function that exists in the shader base class, starting at line 88. And before we render, we need to set up the texture. So on line 90, we activate texture 0. There's a couple of slots that you can use in your shader for textures. I think there's 16, or it goes up to 32. So you can actually have up to 32 active textures per shader. So since we only have one texture, we're going to load it all into slot 0. And then since that's now the active slot that we're working with, we're going to bind our texture by using the texture ID that we saved. And then on lines 92, we apply that texture to a uniform. So and we already have the uniform set up. Like I wrote in little notes right here, it's a predefined thing. We created a couple lessons ago called uMainText, and it's when we created a function in shader util. We create a function called getStandardUniformLocations in our shaders.js file. So if you want to go look, you can see it. It's right there. We call it main texture, and it's applied to uMainText. This way, we already have the location set up and ready to go. We kind of already prepared this. Our framework is kind of like always preparing for a couple of lessons in the future, because this way we're not bouncing around so much. That's how I'm doing it. So this way, it'll save us a lot of time in future lessons, just to, foreshadow things in older lessons. Now we're going to continue on with this page, and now we scroll down near our shaders, and you'll see that right line 103, right after the canvas and div layer, we're going to add an image tag, and this is going to be the shader or the texture you want to load in, and we give it the ID, name, image, text, so this way we can load it up in our onload event. And I add a style display none because we don't want to see the image. We want to load it into the page, but we don't want to be able to see it. We'll see it once we start rendering in WebGL. Now we're going to start modifying our shaders a little bit. So I'll kind of highlight all the things that are new since our previous lesson. So 113, we're setting up an outgoing variable that's going to be pushed out to our fragment shader, and all it is going to hold our UV coordinates. So it's going to interpolate pixel to pixel between the two, or between all four vertices. That's that's the only 2 lines of code needs to be changed in the vertex shader. Now if we go to fragment shaders, line 124, we're going to add the input. So the vertex shader pushes out, and fragment brings it in. Then right after that, we set up a uniform. That's like the 3rd line in our pre-render that we're doing. We're applying our texture to this specific uniform that exists in our fragment shader. And then the last thing we do is 129, is that we used a texture function. We tell it the uniform, which basically is our actual texture, and we are passing in our UV coordinates. And it's a little weird the way it's doing it. I think I don't even need to say vec2, because I think I can just say text coord. But I guess I did it this way to kind of illustrate that UVs, even though it's so strange because it's a UV. You know, I would expect it to be just called UV, but it's sometimes called ST. Its actual coordinates. I really don't know what ST stands for or what UV stands for. In all honesty, all it is an X and Y coordinate. That's how it actually really works. So even though it's called a UV, the coordinate is ST. It acts and works like XY. So, but that's what we're doing. So all of this thing is doing is grabbing the texture and getting the pixel that is on that X and Y coordinate. And that's all it's doing. So now if we go to our browser and refresh, you're going to see a blank screen. Nothing is rendering. And if you open up the console, you'll see this weird error. Now, there's actually a security thing that if you're loading an image from your hard drive, it just won't let you use it in WebGL. It's a security risk because you're pushing an image right into your graphics card memory, and that's could be considered a security risk. So now there's only two ways to fix this. One is the first one is the most cumbersome, and it requires you to set up a web server and then have everything run through a web server. So this way there's no cross-origin image error because it's coming from your hard drive instead of from the internet. The second option is to go through whatever settings your browser has that allows you to disable this security check. Since I use Chrome for all my work, I know how to set it up for Chrome, so I'll just quickly show you how you set it up for Chrome. So the first thing you're going to do is make a copy of your Chrome shortcut. So I have a shortcut on my desktop. Right-click in Properties. Now, in your Properties window, there's going to be a target that has the the path to the executable for Chrome. Now, what you have to do is add in two parameters after the executable. And in my text editor, I just zoomed, I wrote the text out so you can see it better. So we're going to go -- disable - web - security space -- user - data - directory, whatever. Basically this way it will start up Chrome with that security stuff turned off. Just make sure you don't go web surfing to very bad sites with that turned on, because I don't want you to mess up your browser. Just when you're done developing WebGL, turn off Chrome and turn it back on. So this with your regular shortcut. Make sure you have two shortcuts, one that disables security and one that just runs it normally. So that's all you have to do. Just change that new shortcut and shut down every instance of Chrome and then start up a new one, and it should work just fine. So now if you have security turn off of Chrome or you have a web server set up, it doesn't matter. When you see the example, now it works. Now our quad now loads up with the texture that we wanted, and ta-da, the end. And that's pretty much it. Now if you want, just go into the code and change the line that loads up our G model and use our multi-quad. And if you change the multi-quad and come back here, you'll just see that all of the random quads now uses our shader as well. It's that simple, plug and play. So that's pretty much it for the lesson. If you want some personal challenges, you can try finding a texture of blade of grass and fix multi-quad to randomly put everything at the exact same wide height, maybe like 1 unit. So this way, and change it to from 10 to like 100 quads, and maybe you'll get to see something that looks like grass. So if you get like a blade of grass texture that's transparent, that might work out very well. It might look kind of nice. Like I said in the very beginning, if you had like an image texture of like Mario, Sonic, or Mega Man, whatever you want, and just use the quads, it might look fun to see a bunch of cartoon characters floating in mid-space. You can just rotate around. Another thing you can do is go into your quad class and just mess around with the UV settings, and you'll see that you can actually use part of the texture instead of the whole texture. So those are things you can do if you want, just for fun until the next lesson, and just to get to learn it and really get to really understand how all this functions. So so yeah, that's the end of the lesson. We've now textured our quads. I think maybe in the next lesson I'm just gonna now go into cubes finally, like how other WebGL or OpenGL kind of just rushes you right into cubes. It takes us. We took the long way to cubes, but we did a lot. We've set up our framework, and we have this little floor, and we learned a lot about optimization before we actually got to cubes. So yeah. So I hope you're having fun. I hope this was a fun little lesson. It's a little shorter than previous ones, or not really. Actually, it's just as long as the other ones. So hope you're having fun. Like, subscribe. So see you guys in the next lesson, and keep coding.